Okay, so now we are doing question 5. So, three-phase four-pole induction motor has the following characteristics: frequency 50 Hz, line voltage 400 volts, line current 8.5 amps, efficiency 85%, slip 4%. The line current lags the voltage by a phase angle of 35 degrees. Use the information in the introduction to this question to answer parts A, B, and C. Calculate the rotor speed of the motor. So our formula for this one is RPM equals 60 times Hertz over pair of poles. And this is just to get our N sync. So NS is the other one we use instead of RPM. So 60 times 50 over, and we've got 4 poles, so 2 pairs. Therefore, we've got 3,000 over 2 equals 1,500 NS. Now, NR equals NS times by 1 minus slip. Percentage. So we've got NS being our 1,500 times 1 minus 0.04, or 1,500 times 0.96 if you prefer. Grab our calculator, 1,500 times 1.96, and we get 1440 RPM. So NR, sorry, bad handwriting. NR equals 140 RPM. Moving on to the next part. So calculate the power factor of this motor. So that's what they did have was 35 degrees. Yep, current line lags the voltage by a phase angle of 35 degrees. So this one is simple as cos 35 degrees equals P dot F. So more simple questions, cos 35, and we get 0.819. So P dot F equals, rounding up, because we're doing to 2 decimal places, 0.82. And that is lagging, because they told us it was lagging. Now, last one, they have C, calculate the output power of the motor. So power equals root 3 times I line times V line times cos theta times efficiency. So that's our output power formula. Power equals root 3 times, now what was our values? I line was 8.5 times by our V line, which is 400, times by our cos theta, so cos 35 times by our 0.85. Oops. Paper. So power equals. So I've already got my cos theta in there, so I'm just going to carry on. Square root of 3 times 8.5 times 400 times, already got the cos theta, so 0.5, and we get 4100.369, so 37 watts. We grab the answer sheets so we can compare. So their first one, they worked out to 1440 RPM, exactly what we did. They actually went to 4 decimal places. That's different. So they put down 8191 lag. In the online exams, it will actually tell you what decimal place, so you're not guessing like we were back in the day. And then they didn't actually need the input power, more this way, for the input didn't actually have to calculate input to calculate output. We went straight to output. So they've got 4099 by just multiplying it and rounding. They're actually off by about 1 watt. Okay, so today we are doing question 2 of ET40 Electrician's Theory Examination, 19th of November 2011. It's a practice question. So, and the following diagram represents three loads, each with a resistance of 78.5 ohms connected to a 400 volt three-phase supply. So I've got a picture just to make our life easier, but I'm going to draw a piece of paper just these make my life easier when I go back for further recording. So first thing I always like to do is do a drawing. This is why they give us clear paper for the exam as well, so you can do your drawings. Because nowadays it's on a computer, you won't get the joy of having the drawing given to you in this way. So we've got 78.5 ohms on each resistor, and we have 400 volts. So first one, calculate the phase current flowing. This is simply 400 divided by 785 because we have I equals V over R. It's just that simple. So we have 400 over 78.5, so volts, 75 ohms, and we'll use style calculator for us. 400 divided by 78.5, and we get 5.095, rounding to two decimal places, that actually ends up being 5.1 amps. Now, next question is calculate the line current, because we've calculated the phase current, so that's the amps here, which is what they asked us to start with. For the line current, it is I line equals square root of 3 I phase. So that is square root of 3 times 5.1. And so we just go times by square root of 3. And we get our 8.825, so 8.83 amps, rounding up. Question 2, continue to calculate the power dissipated. So our three-phase power formula in this one is power equals square root of 3 times I line times V line. There is no efficiency or power factor for this, or if you were putting them in, it would be a value of 1, so we don't need to use that. So power equals root 3 times I line, which we've already calculated, 8.83, times by our V line, which is our 400. So grab our calculator again. We've still got the value from before, so times by, looks like I can get out of the bracket, times by square root of 3. So that essentially becomes 3. Get out of that bracket, 1. So we've got 8 times square root of 3 times by 400. And that gives us 6114.649. So 65 watts. And our next question is calculate the power dissipated if the three loads were connected in star. So P delta over 3 equals P star. So in this case, P delta is our 6114.65 over 3 equals our P star. So we just go divided by 3, and we get 2038.216, so 2 watts. Next one, which is most appliances sold in New Zealand are designed to operate at 230 volts or 240 volts. An electric heater is rated at 2 kilowatts when operated at 230 volts. Calculate the power output when supplied at 240 volts. So we're going to use the formula P equals V squared over R. So our formula can be rearranged to R equals V squared over P. And the reason why we're doing that is we're trying to calculate R to start with. So R equals 230 squared over 2000. And we get our calculator. We go 230 squared divided by 2000. And we get 26.45. And now we want to calculate the new power. So power equals 240 squared over 26.45. And we can now get our value, 240 squared divided by answer. And we get equals 2177.69 watts. We go and grab the answer sheet wherever I put it. Going with our answer sheet, so A, they came up with 5.1 amps, matching me exactly. Then for the next one, they have 8.83 amps. We got 8.83, once again, matching exactly. For question 3, 6114.65, they're out slightly, and don't know how they accomplished that because that'll be their rounding, square root of 3 times square root of 3. And then they've used the same divide by 3 to get the answer there. So they are out by a fraction of a watt, but it's fine. And then you can see there's two methods to do this one as well, because you can actually do the way we did, or you can do the alternative solution, which is V2 divided by V1 squared times the watts. So 240 divided by 230 squared times 2000, which will increase your power slightly.